Over the next few sections, we're going to talk a lot about quadratic functions. A quadratic function is a function that takes this shape. So we have a times x squared plus b times x plus c, where a, b, and c are real numbers, and a is not equal to 0. We've already seen some quadratic functions. Let's look at some examples of things we have seen and what we haven't. This is a quadratic function. This is one of the parent functions you had to memorize. Here a is 1, b and c are both equal to 0. In other words, you could write it like this, and it would fall into this category here. We know what the graph of this looks like. It's a parabola. It's U-shaped, and because the coefficient in front of that x squared is 1, it's pointing upwards. In fact, we could draw the xy axis, and we know it goes through 0, 0. This is just a real basic review. It looks something like this. Some other quadratics we've seen, things like this, x squared plus 1, and we've also seen x plus 3 squared, and you could even put a -1 on the outside. And we know what the graphs of these look like as well. This function here is just the parabola shifted up 1, and this function here is the parabola shifted to the left 3 and down 1. Now you could FOIL this out. Notice that this will end up being x squared, this function right here, is x squared plus 6x plus 9 minus 1, which is x squared plus 6x plus 8. Now, we gave you this function when we wanted to graph it, but again, you could FOIL it out and subtract this 1, and you will get it in this form, which looks just like this. Now, another example. Now, I said that these functions have real numbers as their coefficients. So here is an example of a quadratic function. Here's an example of a quadratic function. This is a real number. It's a fraction. You could say 7/2 instead of 3.5. And we can also get things involved like pi x squared minus root 2x plus 1. This is a quadratic function. So again, quadratic functions have an x squared term in them. So the coefficient in front of the x squared term cannot be 0. And this number here, this number here, and this number here can be any real number. Let's talk about zeros of a function. So let's recall that a zero of a function is an x-intercept. So the zeros of a function are the x values for which f of x is equal to 0. So these are also the x-intercepts. So when you find the zeros of an equation, You're looking for the x values that when you plug them into your function you get 0. And you can write them as an x-intercept where you put that x value, comma 0. This is a point, and that's known as your x-intercept. So to find the zeros of a function, you're going to do exactly what you did before when you find x-intercepts. What we're going to do is we're going to learn different ways to find the zeros, or the x-intercepts, of a quadratic function. So let's talk about how we can find them. So there's several ways. The first way is to graph the function. Let me give you an example of this. Let's say we have x squared minus 4. This is something we can easily graph. So this is the parent function x squared, shifted down 4 units. And if we use some computing software, we can find the zeros just by seeing where they cross the x-axis. Now, by sketching the graph, you might not do a perfect job of seeing where it crosses the x-axis. You can see that already from what I've done. This side is a little bit bigger than this side, and that's just because it's the way I sketched it. I know I have an idea of what it looks like, but I would need some graphing software to really see what these x-intercepts are. And some of the quadratic functions that we're going to see, like for example 3x squared minus 4x plus 1, we don't even know how to graph those at this moment. So this is not going to be a good strategy for us. The second thing we could do is we can use square roots. So let me take square roots here. Now this is an algebraic way to find the zeros of a function. What you're going to do is you're going to set the function equal to 0. So let's say we had f of x is equal to x squared minus 4. We set it equal to 0. We move the 4 over, and then we can take the square root. So x is going to be plus or minus 2 by taking that square root. And that will give you the zeros of your function. Now this is a good strategy when you have something like this. Okay, or if you have make some space here. If you have a function like this, where this was a translation of moving the graph to the left 3, if we set this equal to 0, we could take the square root, and we'll do this in a bit, but we could take the square root of both sides, and we could solve for x. But sometimes this method won't work, and an example of when it won't work is when you have something like this. Now this won't work because if you set it equal to 0, well, here I had something that was squared. If I move everything that's not squared to the other side, then I have x's on both sides of the equation. And you want to take square roots when the x is only on one side of the equation. So taking square roots is not going to work for us for all the problems we're going to see. But again, I'm just listing some different ways that we can find the zeros of a function. I'm going to show you examples of most of these. We're not going to do any graphing this section. We'll do that in the next section. But we're going to take some square roots. So another thing we can do is we can do something called completing the square. That can help us find zeros. We can factor. But again, sometimes these methods won't work. for every problem. But the one that will work no matter what is something called the quadratic formula. But this formula is a little complicated and you don't want to always use the quadratic formula. So I'm going to give you several examples of problems where we want to find the x-intercepts. We're going to take square roots, we're going to complete the square, we're going to factor, and we're going to use the quadratic formula. And then the idea is when you see a problem on your homework, you choose the method to find your x-intercepts that work best for you. You think that's going to go well with the problem you have. Okay, so again, we'll talk about all of this, and we'll see plenty of examples. So something I want to ask is, if I give you the equation of a parabola, so the equation of a quadratic formula, how many zeros are actually possible for a parabola? In other words, how many times can the graph of your function intersect the x-axis? Because that's what a zero is. So let me write this other question. Another way to phrase this question is, how many times can a parabola intersect the x-axis? So these are the same question. Well, all of our quadratic formulas, which take this form, they can be graphed, and they can be graphed on this xy plane. Now, a parabola is either going to be pointing up or it's going to be pointing down. And we're going to learn how to graph these, but I just want to talk about how many different shapes we could get and how they could cross the x-axis. So for example, I can even give you a good equation. F of x is equal to x squared plus 1. This is a quadratic. It goes through 1, and it looks something like this. You see that this function doesn't even intersect the x-axis. So that tells me that this function is never equal to 0. In fact, you can look at the range of this function. The range of this function is from 1 to infinity. It never crosses this x-axis here. And you can also see this algebraically. If you set this equal to 0 and solve, you'll get a number being squared as -1. There's no solution to this equation here. So it's not possible for this parabola to go through the x-axis. So for this particular parabola, you have no zeros or no x-intercepts. So instead of what's, I meant how. Sorry about that. How many zeros are possible for a parabola? One option is 0. So how many times can a parabola intersect the x-axis? One option is it can intersect it no times. Of course, we could have something like, let's say g of x is equal to x minus 3 squared. This is a parabola, and it is the parent function x squared moved over 3 units. Now the vertex of this parabola, which means the point right here, it touches the x-axis, and no other portion of this graph touches the x-axis. So it will have 1, 0. So it's possible to have 1, 0. And again, you can set this equal to 0 and take the square root. You'll see that the only solution for this is 3. So when you plug in 3, that's the only number you can plug in to get that this function is 0. And you can see it by the graph. And of course, you can have something like h of x is equal to let's move it down 4 units. So let's take the parabola and just move it down 4 units. And again, this is a sketch, but the idea is you can see that it crosses the x-axis 2 times. Now, anything else you draw, any kind of graph you draw that involves a parabola, if it's upside down, right side up, move it up here, move it down here, the only number of times it's going to cross this x-axis is it's going to cross it 0 times, 1 time, or 2 times. Okay, so these are the total number of possibilities for the zeros of a parabola. So when we solve some problems, when I give you a quadratic function and I ask you to find the zeros of it, or the x-intercepts, you could get no solution, you could get 1 solution, or you could get 2 solutions, but you can't get any other number of solutions for your parabola. If you get more numbers than 2, let's say you get 5 solutions, then you've done something wrong, because the parabola cannot intersect the x-axis more than 2 times. So the first method we're going to look at is factoring. So I want to find the zeros of the following equations by factoring. What I'm going to do is I'm going to scroll down and I'm going to show you all the problems. Maybe you can write them down, watch me do 1 or 2, and then try to do the other ones on your own. And if you get stuck, watch the video, fast forward, and see how I solve the problems. So the first one is x squared plus 4x. The second problem is 5x squared minus 45. Here's the third problem, x squared plus 7x plus 6. Fourth problem, x squared minus 8x plus 15. Fifth problem is 3x squared plus 5x plus 2. Then I have g of x is 4x squared minus 2x minus 6. I think that's all of them. Yeah, that's all of them. So we have 6 problems to do. Let's try this first one. So I want to find the zeros by factoring. So we have to remember what it means to find zeros. We have to set f of x equal to 0 and solve for x. So just set this equal to 0, and then we factor this right hand side. So we have to review how to factor. When we want to factor something, we always start by taking out the greatest common factor. We look at what we have and see if there's something we can factor out. Both of these terms have an x in common, so I'm going to factor that x out. Okay, now I have 2 things being multiplied to equal 0. That tells me at least one of them is 0. So I get x is 0 or x is equal to -4. So these are the zeros of my quadratic function. So if I plug them in, I should get 0. So you can see if I plug in 0, I get 0 squared plus 0 is 0, which is true. And then if you plug in -4, you'll get 16, and this will be a minus 16, which will give you 0. So what we're doing is if we wanted to graph this, right now at this point, we don't really know how to graph it, but we do know that our graph, however it looks, it goes through the point 0, 0, because this is an x-intercept, and it also goes through the point -4, 0. So somewhere out here. And something I can go ahead and tell you is because this is a positive number in front of this x squared, is a positive 1, the graph is going to look something like this. Although I don't know at the moment what the vertex of the graph is, this is the idea of the graph. So the graph is going to intersect the x-axis 2 times. We don't need to graph it at this moment. We're just trying to find the zeros. That's all the problem asked us to do. So here's our next function. G of x is equal to 5x squared minus 45. We want to find the zeros. So what we do is we set the function equal to 0. And then we ask ourselves, is there something we can take out, a greatest common factor? The answer is yes. We can factor out a 5. So that is 9. And we can actually divide both sides by 5. We can always divide by a non-zero number. So divide by 5. We get 0 is x squared minus 9. Now, you need to remember that you can factor this by using the difference of squares formula. This is a formula you'll need throughout your math career. It says that a squared minus b squared is a minus b times a plus b. Here, notice that 9 is the same thing as 3 squared. So here's my a, and b is equal to 3. So this factors into x minus 3, x plus 3. So set each piece equal to 0, and you'll get x is 3 or x is negative 3. So those are our 2 zeros. Let's try this third equation. We want to find the zeros, so we set this equal to 0 and we factor. Okay, so this is a trinomial. Notice that there's not a greatest common factor, so I can't factor anything out. For trinomials, what we do, at least this is what I do when I want to find how to factor a trinomial. If the number in the front of the x squared is a 1, which here it is, we take this number 6 and we put it at the bottom of this x, and we take this number 7 and we put it at the top of the x. What I want to do is I want to find two numbers that multiply to give me this number on the bottom, which is 6, and at the same time they add to give me 7. Okay, so 6 is 2 times 3. All right, so what can I do? Well, in order to multiply to give me 6, they either need to both be negative or both be positive. And because I want them to add to give me a positive 7, they should both be positive. So if I take 6 and 1, multiply them, I get 6, they add to give me 7. Those are my two numbers that I need. So as long as this coefficient in the front is a 1, this will factor into x plus this number times x plus this number. You can double check this by foiling. If you FOIL it, you should get exactly what you see here. Let me erase this so we don't get a little confused. So since I have this factor, now I set each piece equal to 0, and I get x is equal to negative 6 or x is equal to negative 1. Those are the zeros of my function. Plug them in and you can double check. Let's try this one. Now this is similar to the last problem. This is a trinomial. Can I take out a greatest common factor? The answer is no. The number in the front of this x squared is a 1. So what I do is I draw an x. I put in the bottom this number, which is 15, and I put in the top negative 8. Okay, I need two numbers that multiply to give me 15, a positive 15, and add to give me negative 8. Now, these numbers can either both be negative or both be positive. If I multiply two negatives together, I get a positive. And I need the sum to be negative, so they have to both be negative. 15 is 5 times 3. And notice if I add those two numbers together, I do get 8. So we're going to say -5 and -3. Once you figure out these two numbers, then we can just write this as 0 is equal to x minus 5. So x minus this, plus this number, which is the same thing as, so x plus a -5 is the same thing as x minus 5. So you don't have to write it this way. And then x plus this number, which is x minus 3. So now that you have it completely factored, x minus 5 is 0, or x minus 3 is 0, which means x is 5, or x is 3, and those are our zeros. Let's try a more complicated problem. Here I have 3x squared plus 5x plus 2. Do we have a greatest common factor? The answer is no. So we're going to do a similar method to what I did just a minute ago. The only difference is I have a number other than 1 in the front. That's going to change a few things. We're going to put this 5 at the top like we did before. But what we're going to put on the bottom is 3 times this number, which is 6. So we're going to do the same thing. Try to find two numbers that add to give me 5, multiply to give me 6. What about 2 and 3? 2 times 3 is 6, 2 plus 3 is 5, so those work. Now that's not the only thing that has to change. Before, I could just say x plus this number and x plus this number when the coefficient was 1. When the coefficient is not 1, I cannot do that. What I'll do instead is I'll break this 5x into 2x and 3x. Let me show you what I mean. So we're setting this equal to 0. We get 3x squared plus 2x plus 3x plus 2. So I just took the same equation. You can see that I brought the 3x squared down and the 2x down. And I broke that 5x into these two pieces because we know that they add to give us 5. Okay, what I do next is I group. So I take the first two and I put them in parentheses. And I take the last two and I put them in parentheses. And then I ask myself, what is the greatest common factor in both of these? What can I factor out? Notice that both of these have an x in common, so take it out. The only thing that these have in common is a 1. So that we can factor out a 1. That doesn't change anything. When you get to this point, so the idea of factoring by grouping is to have the same thing in these two spots. If you have that, then all you have to do is write that piece here and then cross this out, and what you have left goes in the second parentheses. Okay, and again, you can FOIL this out and you'll see that you'll get 3x squared plus 5x plus 2. Okay, now that we have this factored, we set both pieces equal to 0 and solve for x. I have one more of these just so that we get enough practice with this. Okay, we ask ourselves first, can I factor anything out? Notice that all of these are even numbers, which means I can take out a 2. So that's the first thing. And now I can divide out that 2. I don't need that. It's not going to affect my x values. It's just going to sit on the outside the whole time, so I can just divide and get rid of it. As long as there's no x here. If you factor out an x, that's a different story. Don't get rid of the x. But if it's just a number, you can divide by it. Okay, we're going to do exactly what we did before. This coefficient in the front is not a 1. So we're going to take that number and multiply it with this -3. That gives me -6. And then I take the number in front of this x, which is -1, and I put it here. And I'm going to ask myself, what two numbers multiply to give me -6? Remember, one has to be negative, one has to be positive, because that's the only way to get a -6. Okay, so a negative times a positive is a negative. At the same time, they have to add to give me -1. So that means this number, the absolute value of it, has to be bigger than this one. So -3 and 2 will work. Multiply them together, they give you -6. Add them, you get -1. Now, these parentheses, I don't need them really, so I'm going to get rid of them. Now we're going to factor this. Now, how we factor it is we take this -x and we break it into -3x and a 2x. So 2x squared minus 3x plus 2x minus 3. I'm pulling these pieces down as well. Okay, so this broke into these two pieces here. You can see if I add them together, I get this -x. Now the next step is to group the first two and group the last two, and then take out what you can. What is the greatest common factor? Both of these have an x in common. Take it out. And then this, you only want to take out a 1. Now when you get to this step, you need to take out the 2x minus 3. So 0 is equal to 2x minus 3. I have the same thing here, so I crossed that out, and I'm left with x plus 1. So now set these two pieces equal to 0, and I get x is 3/2 and x is -1. I think these are similar to our last answers. They're very similar. Okay, so those are our answers. Let's move on. So another method we can use is the square root method. So let's find the zeros of the following functions. Again, I'm going to show you all the functions and you can write them down. And we're going to use this method. So maybe watch 1 or 2, try the others on your own, and just make sure you get the right answers. So the first function is f of x is x squared minus 18. Then we have g of x is x plus 2 squared plus 1. H of x is 3x minus 2 squared minus 75. And that's it. That's all the problems. I didn't think you would need that many problems because these are kind of easy to do. Now, why do we want to use the square root method on this one? You don't have to. You could try to use the difference of squares, but this isn't a perfect square, so you might run into some trouble with that. So factoring is probably not the best idea, especially if you can't figure out what you need to put as, because remember it was a squared minus b squared is a minus b times a plus b. But if you don't know, you can see that a has to be x, but if you don't know what b is, maybe that's not the best method for you here. But if we set it equal to 0, then we can move 18 to the other side. And now we can just take the square root. So when we take a square root, we get a positive and a negative square root. I want you to pay attention to that, okay? You always, whenever you do a square root, you should get a positive and negative. Okay, let's simplify this square root 18. Now the square root of 18 is the same thing as the square root of 9 times 2, because 9 times 2 is 18. We can break that square root of 2 like this. This, if it's multiplication on the bottom, then you can break it as the multiplication of root 9 times root 2. And this is a perfect square, so this is 3 root 2. So that tells me that x is plus or minus 3 root 2. So you're getting two answers. You're getting that x is 3 root 2 or x is negative 3 root 2. When I write plus or minus, that's what I mean. We have two solutions. Let's try another one. Okay, so here I have g of x is x plus 2 squared plus 1. The reason factoring wouldn't work here is because in order to factor, you need to FOIL this out, which is going to take you a minute. Then you're going to add 1, and then you're going to have to do the x, like this, the x that I made earlier. And that takes time, as you saw, and it takes you a while. But this is going to be a much quicker way, using the square root method, to solve this one. Because if we just set it equal to 0, and then we move the 1 over, we can just take the square root of both sides because I have something being squared. So if I take the square root, I get the square root of -1 is x plus 2, plus or minus in the front, remember, whenever we take a square root. And then you're going to see you have a problem. You're going to see that you can't take a square root of a negative number. So this actually has no solution. And you should probably have stopped here, but it's okay if you didn't notice it at that time. You have a square of something equaling a negative, which is not true. But what would happen, I actually want, just so we have some practice, let's put a -1 here. So let's say the function was actually x plus 2 squared minus 1. Let's compare these. So if we set this equal to 0, and then I move that 1 over and take the square root, I could continue my work because the square root of 1 is just 1, so I get plus or minus 1 is equal to x plus 2. And then you want to solve for x. So you need to move this 2 to the other side. So I'm going to subtract 2. I'm going to get -2 plus or minus 1 is equal to x. You see how I moved the -2 over here? And so I'm getting two answers here. What are my two answers? I get that x is equal to -2 plus 1, or x is equal to -2 minus 1. That's what the plus minus mean. I don't change the negative in front of that 2. So my two solutions are -1 or -3. We have one more problem to do of this type. Okay, here I have h of x is 3x minus 2 squared minus 75. Again, I'm going to set this equal to 0. Move the 75 over. And then take the square root. I'm actually going to flip this because I find it a little hard to work with. So let's flip that. Okay. Now, we're going to solve for x. So I need to get rid of this 2. Add 2 to both sides. And then solve for x by dividing by 3. So x is 2 plus or minus square root 75 over 3. Now let's simplify this, okay? So I have to think. 75, that's like 3/4, right? So 25 times 3. This is a perfect square. So square root 75 is the square root of 25 times 3, which is the square root of 25 times the square root of 3, which is 5 root 3. So instead of this 75 here, I'm going to erase it, and I'm going to put 5 root 3. Okay, so from there, I'm basically done. Let's write our two answers separately. So x is equal to 2 plus 5 root 3 over 3. That's one of the answers. And x is equal to 2 minus 5 root 3 over 3. That's the second answer. So this way we've written it, we're getting two answers in a condensed state.